bicarbonate buffer. And I've already completed a couple of steps of this experiment, which you saw in class earlier today. But I will go ahead and start on page 506 of our advanced biology book and start with procedure, step number 1. So this experiment will work correctly only if you avoid contamination. If you remember this morning, I challenged that theory and told you that the original set of cabbage leaves was boiled with just regular tap water, and I hadn't bothered rinsing any of the supplies with distilled water. So this part of the experiment is like part 2, because we're going to see if it maybe works a little bit better, having rinsed everything ahead of time with the distilled water and performing the experiment all with distilled water. So everything was clean before the experiment started, and we laid it out. I had washed my hands, rinsed them thoroughly with tap water, and then again with distilled water. I already did step 2 also. I took a few leaves of the cabbage and put them into a pan, boiled them with approximately 3 cups of distilled water, and then allowed them to boil for about a minute, took them off the heat, and let the pan cool this afternoon for some time. Then I poured about a half of the liquid in one glass and about half of the liquid in another glass. None of the cabbage leaves went into the water, and you can see I have about equal amounts. Now, step 5 said, what I have in each glass is a solution of anthocyanin, which is an acid-base indicator. You guys have used this before in many other classes, elementary chemistry, high school chemistry too, I remember it from last year. So, what this indicator does, it turns blue in the presence of a high pH and pink in the presence of a low pH. The first difference that I noticed right off of the bat is that my pH indicator that I had this morning, that was not made with distilled water, it was just made with tap water, at my guess, it being more of a blue presence, then it probably had a slightly higher pH to begin with. So in between, then it's going to turn several different colors. So right now, it is a light purple, and that indicates a pH of roughly 7. I'm going to put about a half of a teaspoon of baking soda in one of the glasses. Our instructions say that we should see the color turn towards green. I'm definitely seeing a color change right off the bat. I would say it's more blue than green. Maybe we could call it a blue-green, but definitely a color change. Now, that's because the bicarbonate ion in the baking soda is a base. The green color is a reaction, and it indicates a higher pH. Now, I'm going to use my tablespoon and measure about 1 tablespoon of soda pop into the same glass that I just put the baking soda into. It's important with this experiment that we use a clear soda, obviously, because if I was pouring, say, I don't know, red pop into this glass, it would affect the color. The clear soda then isn't going to have an effect on the color. We're just looking for a change because of pH change. So, whoops, a little more than a tablespoon. I'm going to go ahead and give it a stir again. I don't see much of a color change. If anything, it looks like it's maybe a slightly lighter blue color, maybe a little less green. And I'm going to go ahead and add 1 tablespoon at a time until it matches the color of the original solution. We're getting closer. I definitely noticed a change that time. I'm tempted to stop using the tablespoon. I'm kind of like, when I cook in the kitchen, I like to just kind of eyeball things. So.
I'd say that one's good.
Being precise is not my forte. Okay, I think that they're pretty close. About as close as we're going to get. Now, according to step 8, we have 2 juice glasses that are they're roughly the same pH. One has a buffer solution and the other one does not. Now I'm going to take an eyedropper and add 2 drops of vinegar to the glass that does not have the buffer. That would be this one. I'm going to stir it and mix the vinegar. Once again, white vinegar is important. I wouldn't want to use, I don't know, balsamic or apple cider because it would affect the color. But, I mean, it says white, but it's clear. I'm going to go ahead and give it a stir. Did you see a color change? I think it definitely looks like a lighter pink. And definitely a distinctly different color here. Now I'm going to take my eyedropper again and add 2 drops of vinegar to the glass that has the buffer solution in it. Is there a color change? I don't know. From my viewpoint, it's like subtle, if anything. Maybe slightly more pink, but definitely did not change as much as this one. Now, I'm going to alternately add drops to the solutions, noting color changes as I go. Definitely lighter. I wouldn't say there's a tinge of blue in that at all. Once again, this one is without the buffer solution in it, and this one does have a buffer solution in it. Did I stir this one yet?
No.
I forgot. I think it was 2 more in each. Let's do 2 more. I don't know, folks. What do you think? The buffer is definitely working in this experiment, but I want to note that it also worked when I used exclusively tap water in the experiment as well. You be the judge.